question that I have been itching to ask you guys, but I've avoided asking it so far, is in successive powers of, let's say, A, when I divide it by a divisor, will I always get a 1? In the cycle of remainders, will I always get a 1? Let's see here. What if I were dividing powers of 4 by 6? So as n takes values 1, 2, 3, 4, 5, 6, successive powers of 4, when I divide by 6, let's see the cycle of remainders. You are well used with this language by now, right? What do I mean by cycle of remainders? N will keep changing. So 4 raised to 1 will be just a 4. 4 into 4 is a 16. 16 is more than 6, so divided. 6 2s are 12. Again a 4. 4 4s are 16. Again divided by a 6 will be left 4. 4 4s are 16. Again a 4. So it's the same thing that I am continuing. So the cycle is of just one value. What this means is 4 raised to any whole natural number divided by 6, the remainder is always going to be 4. And this was a question in CAT also. 4 raised to some value, 4 raised to 90, 96, something like this. Divided by 6, what is the answer? So, all those who work with Fermats and Eulers and so on, just miss out a simple straight question like this. Let's just write the cycle and your answer is immediately there. Let's take another question. Let's say what if it is 5 to the power n divided by 15. Why I'm doing this is, let's see if you can notice what is the difference compared to the previous examples that we did. Also try to think what are the conditions of Euler. It will obviously be a condition Fermat also. So what is that one condition which is non-negotiable? Euler's is for any divisor, it need not be prime, but there's still one condition. Anyway, let's find the cycle. 5 raised to 1 will be a 5. 5 square, that is 25. 25 divided by 15. 15, 10. 10 5s are 50. Divide by 15. 15 3s are 45. 5. 5 5s are 25. 25 will give me a 10. 10 5s are 50. Divided by 15. 45 left over 5. So 5 10, 5 10, 5 10, 5 10. There will be a cycle of two different values. But then you don't get a 1. That is what the question that we started with. Some more. What if I have a 2 raised to n? Let me think. Divided by 14. So the cycle is going to be now of 2, 4, 8, 16. 16 is more than 14, so that's a 2. Oh, again 2. 2 2s are 4, 4 2s are 8, 8 2s are 16, again a 2. So this will be a cycle of 3 different values and without a 1 coming into picture ever. 2 raised to n divided by 24. The cycle will be 2, 4, 4 2s are 8, 8 2s are 16, 16 2s are 32. 32 is more than 24, so I'll divide it by 24 and that will leave me a remainder of 8. 8 2s are 16, 16 2s are 32, which will give me 8. And 8 2s are 16 and it will continue. Watch the cycle now carefully. So there are this 2 and a 4 which are outliers. Why do I say outliers? What are the remainders as we go further ahead? They are 8, 16, 8, 16, 8, 16, 8, 16. But the first two are different in the cycle. So is there a cycle? Yes, there is a cycle of 8, 16, 8, 16. But the cycle does not begin right from the start. So watch out for such examples. Yeah, so we are still thinking what is different in these questions than earlier. Let me put in a googly question first. How about if it was 6 raised to n divided by 8? Actually, I could have done it here itself. So 6 raised to n divided by 8. The cycle will be 6 are 36, 36 is divisible by 8. So 8 is divisible as in the sense it is more than 8, and so you'll have to divide it. 8 fours are 32, 4. 4 6 are 24. 24 is again bigger than 8, so when you make groups of 8, what is left over is a 0. 0 into 4, 0 into 6, sorry, is a 0. 0 into 6 is a 0. 0 into 6 is a 0. So, what's happening here? It's not very difficult here. So, think about it. 6 when divided by 8. Obviously, the remainder is 6. Think in that analogy way, 6 into 6. The moment I do 6 into 6, that's a 36. 36 marbles, group of 8, 8, 8, 8, 32, 4 are left over. The moment I do a 6, hang on before you go to 216. What's happening is, can I cancel out the 2's? 2, 2, 2, can I cancel this out? So we have come back to this. So when I cancel this out, this becomes a 27, 3 into 3 into 3. What this means is, in language of remainders, what does this mean when the divisor gets completely cancelled? When it gets completely cancelled, it means that it's a multiple of the 8. So 6 cube is a multiple of 8, and if it's a multiple of 8, obviously the remainder is 0. And if 6 cube is a multiple of 8, 6 cube into anything else, 6 raised to 4, 6 raised to 5, 6 raised to 6, all of them are multiples of 8. Then why did I not get it in the previous one? Remember, this is not a multiple. There is still a 2 left over. It is not a multiple. This as in 6 square is not a multiple. Neither is 6 a multiple of 8. It is only at 6 cube. So it is only after this that the remainders become 0. Initially it is not 0. Something very similar to the previous one. The only new thing is that it becomes a multiple, hence remainders are 0. So what is different now? The difference is that your divisor and dividends are not co-prime. And so I hope you get the idea. In both Euler's we had the remainder was 1 only when the divisor and a is co-prime. Here they are not co-prime. So if the numbers are not co-prime, if there has a common factor, remember we will not get 1 as the remainder. The cycle will start repeating without getting 1 as a remainder. Does it really make a lot of difference to our question? Not really, but we need to learn one funda. That is what we are going to do next. It's an important one. You cannot miss it or avoid it.